guys. Today I want to show you some animation about the two slits experiment in quantum mechanics that explains a little bit the superposition principle and the difference between single particles in quantum mechanics and single objects in classical physics. So let's start with a simple idea. So we have two, as we can see, we have two slits, one white and one blue, and they are shooting balls or bullets, if you like, from the slits, and depending on the trajectory they get, they will arrive at the end, at the bottom of the screen, with some distribution. This is a statistical thing. Each bullet will have its own trajectory. They will not talk to each other. Maybe they will bounce off with some elastic mechanics there, but they know what to do. And if we stop this, we can argue that the distribution of the bullets at the output of the screen will grow in this way, like a Gaussian. You will have two sets of distribution. Okay, the one in the middle is wrong. It's not there. I can just remove this one, show it again. So run double slit. Yeah, as you can see, they will grow, and then in the end there will be two distribution that will look like Gaussian. Okay, now what's the difference when we use waves, for example? So if we open two slits and we run two waves, we have this kind of image. As you can see, white and blue waves that will grow in time, in burst, but it's a continuous pulsing. So you will have a distribution that, if you look at the end of the distribution, will look like the one that I will show you in a sec, which is this one here. Let's see if this arrives. So remember, these are classical waves of light, and this is a distribution. Okay, so you'll have some fringes, interference fringes between the two lines in a single shot, because the two waves are superimposing on top one of the other, the blue and the one. Now, what happens when you have single photons? The difference is that when you have single photon, you have the same as this experiment here, the same as this. You have photon, except that at this time they are not at the same time. Each of these is a single photon, so you have to imagine that these are many repetition of the same experiment. So there won't be two photons or many photons at each time. It will be just superposition of many photons at the same time. And what will happen is that they will, at each event, they will be detected at the screen. So they will grow like interference patterns, creating the same patterns as we saw before in waves, but with a particle wave, with a particle-like behavior. Basically, each event will correspond to one click on the screen, as we see now. We can see it again. Each event of the photon will be detected in the screen, growing the statistic, but overall the statistic will look like an interference patterns that we showed before with the waves that happens at the same time, which is this one. So when the wave happen at the same time, when those two are interfering, you have this pattern, and then you can have multiple intensities at the same location. Okay, so I hope this complete a little bit the video on YouTube about the double slit experiment with a bit more detail. I hope you liked it, and stay tuned for more videos. Next time maybe we'll talk about entanglement or other kind of symmetries. See you. Thank you.